Hello and welcome back to Eliminate. So we're discussing on type 1 and type 2 error. As we continued in the last session, we did know about alpha, beta, 1 minus alpha, 1 minus beta. Let's continue with that and take the ideation a little forward to understand them further. Let me again redraw the confusion matrix to keep it aside. So you're taking the same case, global warming, no change in temperature, null hypothesis, alternate hypothesis, at least more than 2 degrees Celsius change in temperature. So we have false positive, false negative. So quickly, this one, type 1 error, type 2 error. Okay, so this is where we are. And then also let's draw the distribution. So we had one for the null hypothesis and one for the alternate hypothesis, right? So this is your alternate and this is your null hypothesis. Okay, so this area here accepts null hypothesis, it's not, and this area is your alpha, this is your 1 minus alpha. Okay, true negative, false positive. Okay, all nomenclatures, again please visit the previous session to understand it in detail. This area is beta and this complete area is nothing but 1 minus beta. This is nothing but your true positive and this is nothing but your beta is nothing but your false negative. So this is where we stand. Now let us break down this alpha and beta. There is an equation. Let's just write down the equation here to understand and deliberate on this to understand further based on sample size. So sample size equals to, or sample size n equals to, what should be the sample size for an appropriate hypothesis testing or a decision making? Okay, so let's Z score or confidence score based on alpha and based on beta. Okay, sorry, Z score based on beta. Okay, the square root of this. Okay, then you just multiply this by the standard deviation square and then you divide it by the effect size. So we'll discuss on all of this. Effect size, again square of effect size. Okay, so let's switch color here. Okay, this thing, okay, let it be just beta, not alpha divided by 2, because one that two tail and the other one is just on a one tail, the beta side, right? So we are just considering 1. You can take it anyway just to understand. Okay, so this is how we have. So as a simple thumb rule, by seeing this equation one can understand if the standard deviation increases, right, that means the sample size has to increase. Okay, if you increase the Z score value of alpha, then also that means you are increasing the confidence level, right? You increase the confidence level, that your sample size has to increase. So these are all the parameters. If you increase the effect size, so what is effect size? So effect we have discussed here is 2 degrees Celsius is the effect that we have. If you want a lesser effect, say the change that I want to detect is 0.5 degrees Celsius, you want it to keep very less, that means you again increase the sample size. Okay, you reduce this, you increase that, it's on the denominator, right? But if you increase this effect, say I want to detect only a 5 degree or 10 degrees Celsius change, very great change, that means you need a very less sample for detecting that. If that kind of a dominant effect is already present in the data, then you have to take very small sample to confirm that, right? So that is how this equation plays a role. Now that can be understood from this particular distribution as well. So if you see alpha, so if you increase this confidence from 95 to say 99% and you reduce the alpha to 0.01, that is 1% basically. If you keep this 99% and you, that means your alpha you are keeping is only 1%, that is 0.01, very less of alpha. So the chances of making type 1 error is very less, very less. Basically type 1 error that you are making is very less. So you are keeping a strict limits on type 1 error. Then what will happen is this line is moving towards the right. Okay, this line now it will get shifted to your right here. This will be a new line. Okay, so your alpha will be alpha dash, which is a smaller area now, this area basically. But what is happening to your beta? You see, your beta, this beta is now getting increased till this point. So your beta is increased. So it's always a trade-off. Beta dash is increasing. So this has increased. So the further you go on the right hand side for your alpha, that means your confidence level that you're increasing by reducing the alpha value, you are compromising on beta. That means false negative. So there are chances, there is probability that you will make a type 2 error. Okay, of accepting null hypothesis. Accepting null hypothesis when it is incorrect. Okay, this is rejecting null hypothesis when it is incorrect. Okay, so that is positive. You are rejecting. You are saying temperature is more than 2 degrees Celsius. That means you are rejecting null hypothesis when it should not have been. So these are the two conditions that you are dealing with. So you have increased in this area, but you have reduced in this area performance wise. So the type 2 error will increase. So there is always a trade-off between these two. That is what we have discussed in the classification problem. You can go back and visit that to again clarify on that. So that is how this plays. So you move these lines here and there, you'll understand what is happening to my alpha and beta. So at last, what is my power of my test? This 1 minus beta. What is my confidence level? 1 minus alpha. So alpha is in your hand. Whoever is the data scientist or data analyst, he can or she can take the alpha value as 5%, 0.05, or maybe 0.01, as strict as required. This is what, so the false positive or the type 1 error is in our check. So this is under check, right? Depends on the case that you're dealing with, you have to keep this in check. You can have a trade-off between these two, right? So now, as you understand here, if you see, one is on the left side, the beta is on the left hand side. So the value for beta, that means this Z score, or which this confidence Z score is taken from the left side area, this part. So this part is your Z score we are taking for beta. And the right hand side part, this part, this is the part where we are taking this area basically, and this point is taken for Z of alpha, right? Based on this curve, left hand side curve. So on the right hand side, Z alpha by 2. So these are the values that we are taking. So these values of Z for alpha and beta will be different. Okay, now let's just take a simple sample calculation and do this. Let's assume the standard deviation is equals to 2 degrees Celsius, your standard deviation. Okay, and let's keep alpha as 0.05. Okay, alpha is standard 0.05. We'll have to get the Z score for alpha 0.05, that is alpha by 2 means 0.0275, or that 97.975. So 0.975, that is 97.5% confidence. If I divide this by 2 and do a 1 minus 2, 1 minus 0.05 divided by 2, and then subtract it with 1. So I'll get this 0.975, 97.5% confidence on this left hand side. Okay, so that is what is our alpha by 2. Then beta is nothing but normally standard again, beta we can assume to be, you can take any value, 0.05, 0.1, 0.2, let it be 0.2 or something. That means the confidence that you are keeping, power of test that you are keeping is 80%. You can increase this as well. So it all is, you have to think through and keep it 80% is your power. Okay, now we'll have to take a Z score for this beta. Okay, Z score for this beta. I'll just show you how to take these values. So if you go to a Z table like this, okay, so this is a Z table. So you have, see, we are speaking about this thing. So on the left hand side, we have to keep this as a null hypothesis 1. So we need the Z score here. So what is the area that we are looking at? 0.975, right? So if you see 0.975, yeah, this particular thing, right? So what is the value corresponding Z value? 1.9, and then towards the top, if you go here, 1.96. Okay, so 1.96. Perfect. So we just write it down here. So this value, alpha Z value, alpha by 2 is nothing but 1.96. Now similarly, if we take Z beta, okay, you'll have to go to the next table, top one, basically here, where you want the left hand side area, this area basically. You're dealing with this, so you want Z score for this. This is your beta. So what is that you are keeping here? You can keep 80%, you can keep again 90%, 95%. What is a power that you require, based on which you want to just calculate. This is just for calculation. It's a trade-off, right? So now let's assume 80%. Okay. So 0.8. Where is it? So it should be, yeah, point. So what is the beta value that we have? Beta value is, what we have taken is 0.2. So 0.2000 whatever. So 0.20, I think this would be okay. Or if you want little less, 0.02005. Perfect. This one, right? Very close to 0.2. This is what you're taking, 0.2. Okay, 20%. 0.2 is the value for beta you're keeping. You can reduce it, okay, to increase the power, if just for example case. So 8 and then 0.8 on the left hand side is 0.8. Negative value because you are looking at the left hand side of the curve. So negative value is not mandatory for us. 0.8, we are just looking at the value, and 0.84. Okay, so this is the value. So we have 0.84. Now just multiply this, just assume that this is approximately equal to 2, and assume that this is approximately equal to 1. So just for the calculation sake, okay. So you have 2 plus 1 whole square into standard deviation is 2 into 4, 2 into 2 square. So 2 into 4, that is 8. Then you divide it by fx size. So if you, for example, you want to measure 2 degrees Celsius change, okay, fx size is 2 square. So you are keeping here 4. So 4 here means 2. Let's cancel it out. 2. So 2 plus 1, 3 square is 9. 9 into 2 is 16. So sample size required for this kind of a test is only 16. 16 samples, you just take it and you measure. You can be statistically saying that, yeah, what you are saying, whether it is that the alternate hypothesis you are accepting or you are not, depends on 16. But if you go for a minor change, say in actual scenario, it might be, say, very less, right? 0.5 degrees Celsius increase from previous. So it then this would reduce to 0.5 into 0.5, 0.25 basically, and then all this will change. All of this, if you change the confidence level, and as you increase it, reduce the effect size, your sample will drastically increase, right? Based on standard deviation also. The more you sample that you collect, the standard deviation is something which is not in your control. This is not something in your control. Not in control? No. So it's not in control. So as you increase the sample, the standard deviation would kind of reduce. Okay. In more sample, it will tend to fall at a a mean value, closer to a mean value, something. So it will tend to reduce. So the more you take this sample, the standard deviation would reduce, and then, so if you want a lesser standard deviation, okay, in that case, again, you'll have to increase the sample size. Otherwise, right, you will have to have a more sample. Otherwise, you will have a more standard deviation, and the more the standard deviation, then again your test will get screwed up. So it's other ways also. Okay, so this is how we are closing the type 1 error, type 2 error, and how does it affect, and what are the parameters that are important when we decide on testing all of this. Thank you for listening. Please do watch the previous videos and like and comment your feedbacks, and subscribe to the channel to keep us motivated in